Welcome to a brief introduction to the technique of refluxing. Now, before we begin discussing exactly how refluxing works, let's consider the problem that it can help us solve. And that is that organic syntheses often require the heating of solutions for long periods of time. Some specific examples of this would be achieving complete dissolution of a stubborn solute, favoring the thermodynamic product in a reaction with multiple pathways, and also increasing reaction rates so that equilibria are reached more rapidly. So all three of these situations beg the question, how can we boil a liquid indefinitely without boiling the liquid away, without losing significant volume? And the answer is we use a technique known as refluxing, which involves recollecting condensed solvent vapor in the same boiling flask from which it originated. Now, before we talk about the technique of refluxing itself, let's take a look at the alternative and why it is we need to reflux in the first place. Now, the simplest way to heat an organic solution is using a water bath or oil bath and a suspended beaker or flask. Now let's take a look at this beaker and see what would happen if we attempted to heat a solution for an extended period of time. Within our beaker, we're going to place two different kinds of molecules, those of volatile solvent, shown in blue, and those of a non-volatile solute, shown in brown. As we apply heat to this mixture, we expect the volatile solvent to boil. So let's do that now and watch what happens to the solvent vapor as it is formed. In this system, as you can see, the solvent vapor is escaping and not returning to the flask. This means that over time, we expect all of our solvent to become vapor and ultimately escape, leaving behind simply a residue of the non-volatile solute. This is extremely undesirable in many ways. We can heat our non-volatile solute and damage it, and of course, when it's out of solution, it's no longer able to react in the way that we hope that it will. So we need to come up with a technique which will allow us to prevent this loss of solvent as it vaporizes. One solution to this particular problem is to use a reflux condenser. The apparatus depicted in this slide shows, as usual, a lab jack with adequate clearance holding a stir plate underneath of a thermowell. So when the lab jack is lowered, the heat source will be removed. The remainder of this apparatus consists of a boiling flask, which is clamped in place since it's the lowest piece of glassware, and a reflux condenser, which is also usually secured with a second clamp, though it's not shown in this demonstration. Another key feature of this apparatus is that the top of the reflux condenser is open to the atmosphere. This is to prevent pressurizing when we heat the system. To close the top by placing a thermometer adapter or stopper or other device into it would be to invite an explosion or a flash boiling event, which would cause a great deal of potential damage and possibly injury. Now that we've reviewed the apparatus, let's take a look at what's going on inside of the actual boiling flask and reflux condenser. Just as before, we're going to charge our flask with a volatile solvent and a non-volatile solute. At this point, we're going to use our reflux condenser as a region of cooling, which will allow our sample to recondense and fall back into the boiling flask. To do this, we attach a water hose and turn on cold water flowing through the outer jacket. The effect that this will have as we heat the boiling flask is to recondense vapor, sending it back to its original location. Let's take a look at this as it happens. I apply heat to the flask, and my solvent begins to boil. But rather than escaping to the atmosphere, when it reaches the cooling jacket, it condenses and falls back into the boiling flask. Therefore, the net change in volume of my solvent should be zero. Using this technique, we can boil organic solutions for extremely long periods of time, for hours and sometimes even days, without significant loss of volume. And this is the benefit of the refluxing technique.